live. Hi everyone, I'm Dan. I'm the resident engineer here at the Supply Frame Design Lab, and I'll be your MC for the rest of the afternoon. I apologize for the bright streak of sunlight that we've got going across the presentations right now. This was a design flaw of the facility that we just noticed about 16 hours ago. So, or actually, I would imagine about 24 hours ago when we were doing the tests. So we gamely tried to go put some covering on that window, and turns out it's not something that we can get to with the tools that we have at hand right now. So I apologize for that. Moving right along, I am pleased to introduce Kwabena, who is going to be talking about OpenMV. He is the co-founder and CEO of OpenMV. He's an electrical engineer who started working on OpenMV because of a love for computer vision and microcontrollers. So I'm going to hand it over to Kwabena.
Can you hear me? All right, great. Okay, so I originally did this talk for the Open Source Hardware Conference. So I just kind of have it in a nice 15 minutes and a little, note sheet just to go over everything. Anyway, hi everybody. I'm Kwabena Agyeman, co-founder and president of OpenMV. And today I'll be talking about how I took my project from a Hackaday fail of the week to a success. All right. So first, what is OpenMV? Well, it looks like you can kind of see that. We're a company dedicated to making computer vision on microcontrollers easy. Our product is the OpenMV Cam. It is a microcontroller programmable in Python, and you can use the OpenMV Cam to take pictures and video along with being able to run machine vision algorithms on images that are captured and stored in its RAM. You're able to do all of this while being able to control I/O pins, use a SPI bus, I2C bus, DAC, ADC, turn I/O pins off and on, interrupts, PWM, etc., the whole plethora of features. And last but not least, it comes with a cross-platform IDE, so you can program it easily, and you can see the frame buffer along with your code window, serial terminal, and a histogram of what's going on all in one nice view. So we're a Hackaday project. That's how OpenMV got started. It was originally my co-founder, a guy named Ibrahim. He created the project on a blog post, pretty much, looking for a better camera sensor. And eventually there's a huge following of people behind that blog post looking to see this product realized. So he then went on and made a Hackaday post about it and kept updating features and such. So as a Hackaday project, we're actually one of the most scalded and loved projects on Hackaday. We have 150,000 views, 2,000 likes or whatever skulls, and many followers. If you go to Hackaday.io and scroll down, you'll see our project is one of the first projects up on there, just in generic project list. Anyway, so a lot of people were interested in the project, and this is how it got steam to go forward and become a real product. Ibrahim actually put the OpenMV Cam into the 2014 Hackaday Prize. We were able to get semi-finalist. We didn't win, but that was a good enough view response for us to go forth and do a Kickstarter after this. And so putting your project on Hackaday and letting people know about what you're doing can really help out to make your product a reality and push you forward to actually help to, for you to develop it and finish that product. So anyway, I said we did a Kickstarter. So with all the enthusiasm from the community, Ibrahim went on to do a Kickstarter. We were able to raise $100,000, and we had 900 backers. Considering how we didn't do any advertising beforehand, this was quite good. Our video was of poor quality, but we had enough people who were interested in the product. I got involved in the product around this time. I was trying to jump ship onto something that was successful, or join something that was successful. I thought I was going to be joining a gravy train. Anyway, OpenMV is an example of, again, how you can take some idea that you're just messing around with and using the community to gauge the response for, do I want to actually make something real out of this, and so on and so forth. Yeah, I should read these notes a little bit more. I actually prepared it a little bit better, but I'm kind of ad-libbing right now. Anyway, okay, so there are other examples of people going from Hackaday to a Kickstarter project too. Before I was making this presentation, I saw a product called Mehcad online, and this was basically a Kickstarter Hackaday project that had gone to a Kickstarter to make a closed-loop stepper motor controller. And interesting enough, their product got a lot of views, a lot of people following it, a lot of people liked it, and this pushed them forward to go on and do a Kickstarter. They didn't raise a terribly large amount of money, but they got $60,000 and enough to build the system and pocket a few thousand personally just for their effort. So by embracing the community, again, you can make something a reality. So anyway, my story. OpenMV Cam. So this talk is about overcoming failure. Like in every story arc, there needs to be some rising action, some conflict, some failure. In OpenMV Cam's story, we chose the wrong camera chip to go into mass production with. In particular, we designed the OpenMV Cam with the OV2640 image sensor from OmniVision. It was a nice chip. It had built-in JPEG compression, which allowed us to take high-resolution pictures and store them on the microcontroller's RAM. In the sense of it having JPEG compression, it would literally just send you a JPEG image byte for byte on an 8-bit data bus, and you would just store it in memory, and you could write that to disk, and you were done. It was also cheap, too, costing $2 a piece. The only flaw, though, was it was an old chip, very old, in fact, from 2006. So these things have been sitting around for 10 years. We didn't think there was going to be a problem when we built them. We thought it was going to be okay. But there were a few issues. Our prototypes worked fine, but so there won't be any problems in mass production, right? So actually, no. We had a 80% failure rate on the cameras. When we went to manufacturing, 80% failure rate pretty much. Thank God we tested them before shipping them to our backers. We were trying to do this semi-professionally. And how did it happen? Well, it turns out that the camera chips have little tiny solder balls in the bottom of them, which go bad over time. So unless they're completely temperature sealed, so completely sealed from the outside world in a humidity-protected environment, the solder balls corrode, they rust, and after 10 years, they're completely worthless. There's no way you can actually put the camera down on the PCB board anymore. So we actually made Hackaday's Fail of the Week because of this. Someone gave an anonymous tip, and bam, our failure was on the front page of Hackaday. So as you can see in this slide, the actual problem in particular is that's the solder ball on the top, and on the bottom you have your solder paste. And there's not really a connection between the two right there. They're physically connected. The camera won't fall off, but they're not electrically connected. And so there's about 28 of these little guys on the bottom of a very tiny chip. And if just one or two fail, you got to start over. Camera's dead. Can't do anything about it. For our own personal production, we were just using a lot of heat with a hot air gun, and that would eventually get it to work. But that also risked cracking the camera chip because it has a little glass panel on the top of it. So there is a difference, of course, between building one unit when you're prototyping and going to mass production and building a huge amount. So a second little bit of tidbit of information is to be careful how you source your parts. So these bad cameras, where do they come from? Well, our manufacturer, Macrofab, we actually got in contact with them, and they let us know that, and they actually went over to OmniVision and asked them, how did these chips come about? How is it that we were able to buy these chips even though it was 10 years old? And OmniVision tracked that down and looked into it and responded with, those chips were only sold to cell phone manufacturers. They were never sold in the open market. So the only way these chips existed was from either people desoldering them from old cell phones and then repackaging them to sell them to poor saps like us, or from them literally just being unused stock that had been sitting around in an open package for 10 years, pretty much. Guess where we bought everything from? AliExpress. Great quality, low prices. Anyway, so be careful where you're sourcing your parts. You may not get what you expect. So At the beginning of this year, the situation was bad for our Kickstarter. We had about $18K of cash on hand from the $100K initially allocated. We had built up 150 OpenMV cams, so for 80% failure rate on them. And of course, these cams were not really repairable. We had 1,450 bad PCBs, and we had another 500 bad camera modules on top of the 1,450 camera modules we hadn't soldered on. So we had about 2,000 camera modules that were worthless. This was a write-off of about 10K pretty much. Last but not least, we had 900 disappointed backers who could easily turn into an angry mob if we didn't eventually get something out to them. So these were dark days. But while we were demoralized and while things were looking really bad, there was a way out. So what I did was I used that 18K to pay for another manufacturing run. I realized that the OpenMV Cam community wanted the camera. They had come in and supported the project. And from all the people who had supported us previously before the Kickstarter, I knew that there existed, this product needed to exist. People wanted it. So we went ahead and worked relentlessly, day and night, every weekend, doing product updates, doing firmware updates to build hype for the product, to make people more interested and want to buy it later on. And we also slowly tested manufacturing of 10 cameras to make sure that we could get it working with a new chip. In particular, we switched over to something called the OV7725. This is the image sensor that we bought directly from the factory, so we completely avoided all of the solder ball problems. And we did 10 at first, and they all worked. And then we did 40, 2 panels to test to make sure they all worked. And again, we were successful. 40 out of 40 worked. So we were able to move forward, hit the button, and go into mass production and build all 1,500 new cams. So this was a long amount of work. All right, so I haven't been reading this thing. I'm totally off sync from what I'm supposed to be saying. Anyway. Yeah, so we did a Kickstarter update every 2 weeks, and we were working like crazy on this to make people aware of all the things we were doing and getting it working. Because of all the effort we put in on updating the product and basically making it better and better every day, our Kickstarter backers actually jumped in and helped raise money for us to ship these products. Because basically we took our shipping money that we had allocated and spent all that on another manufacturing run. But in the end, the results were worth it. We were able to build all 1,500 and ship them all to our backers. And so this is a picture of someone finally receiving their OpenMV cam. So what did I learn? And let me kind of resync myself to my notes here. First, you need to get the community, obviously, as I said before, involved in whatever project you're doing from day one, and blog about what you're doing it, talk about it, whatever you can do. That's kind of why I'm here, doing a little bit of marketing and talking about the product, trying to get rid of the rest of the units that we have on stock. In general, don't develop your idea in isolation. Previously, I had spent 1.5 years working on an IDE that made it easier for your Arduino to do graphing on it, like you built the ability to automatically generate graphs and user interfaces when you connected your Arduino to the computer. It was really nice and powerful, but no one wanted it, so I spent 1.5 years working for nothing. Whatever the case, getting the feedback will let you know immediately if you're going on the wrong path. Second, you're going to need grit to do the Kickstarter project. So if you're doing it, you're not going to get any pay. In our particular situation, I've been working nights and weekends and more or less getting that project rolling without any pay and any so forth or any kind of, just basically sacrificing to make the product worth it, because I believe that if I got through this hard moment in time, we would get something that's good on the market. People will be willing to buy it later on. Also, make sure you're passionate about what you do, again, because you'll need that to have that kind of grit to go on and forth and make your product. Also, biggest thing, do yourself a favor and plan what could go wrong before you make the thing, and try to figure out ways to recover if you can. In our particular case, we had spent all of our security buffer money on paying the 2 founders originally of the product. And this put us in a very tight situation later on in time. So by saving all your money and not spending it and using just what you need wisely, it'll make it a lot easier unless you get into a hard situation. Second, well, next slide. So verify your manufacturing process, and don't go out and buy a ton of parts immediately. One of the particular problems we had was we had all these extra camera sensors that we had to throw away pretty much. If we had just bought a small quantity and didn't go out and spend thousands of dollars buying thousands of sensors, we would have learned about this particular problem immediately and not have blown so many PCBs and camera sensors on it. Other projects have died from this. Has anyone heard of Xano? No? Okay, well, Xano was a Kickstarter project that raised $3.4 million. I think it was the biggest one ever. And there was a whole fiasco on them doing a product video where they were showing off a product that didn't actually work the way it did in the video. They were kind of making that up. And they got a ton of funding. They went ahead to build their system, and they basically bought all of their parts immediately. And because of that, they originally figured out, though, so they were building a drone, pretty much a little drone that could take a picture and follow you around. And they bought tens of thousands of propellers for their drone. But when they went to go build it, they found out that the propellers were too small to make the drone fly. So instantly they had a huge write-off from all those propellers that they had to throw away. So spending all your money up front before you do your manufacturing is a terrible idea. Instead, verify your manufacturing in small steps and try to get up to a large bulk order. That way you can make sure that nothing goes wrong in the process. Also, updating your Kickstarter constantly and being transparent as possible makes a huge difference. We were lucky not to get besieged by a bunch of angry email messages because we updated every 2 weeks. Anyway, that's all. Nice and short, simple talk. I should have followed the script a little bit more. Thanks for listening. And also, before I go, I just wanted to give a shout out to Macrofab. They're our contract manufacturer, and they stuck with us the whole way. They were actually in charge of diagnosing this problem. They were basically trying out all kinds of medieval methods to make sure those solder balls worked. They actually tried grinding the bottom chips, using extra heat, dipping them in acid, reballing them, all kinds of crazy things to make these cameras work before we finally gave up with the OV2640 camera chip and switched. And during this whole time, they were basically losing money, but they kept their word and kept working with us as a product to make sure we could get out the door. Anyway, that's it. Thank you.